Hey there. So in this video, we're going to complete our classification notes, which is packet page 105. So now that we have a better understanding of how organisms evolved and how they can change over time, we are going to take a look at how scientists classify all of the living things that we see here on Earth. So this science is called taxonomy. Oh, well, I spelled that wrong. That figures. Taxonomy. Sorry about that. So taxonomy is the science of grouping and naming organisms based on their characteristics. So physical characteristics that we see in different organisms. So do they have fur or do they have hair? Do they walk on 2 legs or 4 legs? Or, an insect, does it have, more than 4 legs? Now, the classification system has not remained the same over the last few hundred years, right? It changes. So a long time ago, we started with, and I'm going to make sure I spell his name right, Aristotle. Aristotle was he was a Greek philosopher, and he developed the first system of classification for organisms here on Earth. Basically, Aristotle classified every single thing into 2 groups. He said they were either plant or animal. Now, his groups were useful, but unfortunately, they did not group organisms according to their evolutionary history. Aristotle didn't really have an understanding of evolution, and so we do not use his system anymore. We know that there are more organisms than just plants and animals. For example, fungi, protists, bacteria. So today we follow the system developed by Carl Linnaeus, right? And this is called a binomial nomenclature, a 2-part naming system. And again, this was developed by Carl Linnaeus, A-E-U-S, Carl Linnaeus. And so basically, Carl Linnaeus, right, he grouped organisms starting very broadly, and then he slowly became more and more specific. So, for example, we start with the broadest level of classification, which is the domain. And then underneath domain, we have kingdom. And then underneath kingdom is phylum. So kingdom, phylum, class, order, family, genus, and species. So domain, right? So it's kind of like an upside down pyramid here where we see domain would cover, right, more organisms, right? Let's say like animals, whereas species is a lot more specific and it's a smaller group of organisms. There are 3 domains that we recognize. Those are eukarya, eubacteria, and archaebacteria. Okay, so those are the 3 domains that we recognize. Eukarya are going to be organisms that are eukaryotic. Eubacteria are going to be bacteria that have or that are more recently developed, And then archaebacteria are the oldest and kind of most primitive of the bacteria. So a quick note about species. So when we name a species, we will use Latin. So when we name a species, we will always use the genus and the species to create, right, a scientific name. So genus and species are the last two levels of classification. So for example, if we think about humans, now humans is kind of just a general term referring to a species, right? Humans, or I could say dogs or cats or leopards. But in science, we've got to make sure we're really specific because there are a lot of different languages spoken around the world. And so a scientist here in the United States that speaks English needs to make sure they can communicate with, a taxonomist, a scientist in Europe, that speaks French. So we created scientific names based in Latin because that is a dead language. So for example, instead of using the lay term human, we would say Homo sapiens, plural, Homo sapiens. So Homo meaning the genus, sapien is the species. So we would know, if I was a taxonomist, we are referring to modern day humans because I'm using the scientific name Homo sapiens versus some of our human ancestors, that might be Homo erectus or Homo habilis. So we share a genus, but not a species. So I can write one of those out here. So Homo habilis. So different species, but we're the same genus. And then another example could be Bubo, and I'm Virginianus, right? This is known as the great horned owl. But again, as a taxonomist, I could use the scientific name, and any other scientist or taxonomist around the world, no matter what language they speak, they would know which specific organism I am referring to because we all understand the scientific name. Along with classification is the science of phylogeny. So phylogeny is the evolutionary history of a species. So it's more than just taxonomy, where the science of grouping and naming organisms based on their characteristics. Phylogeny is when I actually look at different species to figure out their evolutionary history. Phylogeny is based on cladograms. Cladograms will have branches that are closer to one another, and then that tells us whether or not they share a common ancestor or not. So for example, I can create a cladogram, so here's my, my starting point. Here's my first species, second, third, fourth, something like that. So I can look at, different organisms, and I can see how closely or distantly related they are based on their evolutionary history. So that is it for our classification notes here. If you have any questions or concerns, let me know. Thanks.